All right, let's start. Today we're going to try to answer 3 questions. What makes software not fun? Where does it hurt us? And can we make it fun? So to do this, we're going to explore 5 topics. The punchline of the presentation is going to be, as you've heard me before, test-driven development to kind of fuel better and faster development. But it's kind of hard to just do TDD, unless you put some conditions in place that will help you out to be successful at it, right? And one of them is operating in an architecture that is conducive to doing test-driven development, but also kind of yields much more flexibility in your applications. So we're going to explore some architectures. We're going to look at object-oriented programming, right? By and large, if we work in PHP, we tend to operate in the OOP paradigm. So we're going to a little bit look at that, kind of how to play to OOP's strengths. Ahead of that, we're going to look in a broader spectrum, kind of what are enablers of better code. And I touched on some of them yesterday, but we're going to dig a little bit deeper into paradigms. And the first thing we're going to look at right now is the effect of bad code on your fun. So, is anybody familiar with Robert C. Martin, Uncle Bob? Okay, all right, cool. Yeah, so he famously said this, right? It will be a long time before I trust software to drive a car I am in because I know, right? He knows how bad software can get. And if you remember Samantha's keynote, right? She touched on some of the bad effects of bad software on human lives, right? We're starting to see a lot of software in cars these days. It's scary how much software drives cars, right? Tesla is pretty famous, for putting a lot of advanced software in their cars, right? They're doing some really, really interesting things. Of course, what could possibly go wrong? I don't know, maybe this, right? So beside that dramatic effect, in general, what takes away our fun in software, of course, you've got inheriting somebody else's code. That's rarely ever fun. Having a hard time understanding how the system works, right? If you can't understand the code that you inherited from somebody else, it's going to be even harder to understand what the system does. It's never fun to also be breaking old things when we build new things. And and we hate testing, right? I mean, it's just, who wants to do that? So now that we look at a little bit some of the pain points of bad code, let's look at some enablers for better code. And so like I said, I touched on these yesterday a little bit. So I like to look at 3 things to kind of promote better code. You could put all this under clean code, but I like to kind of separate things out a little bit because it kind of helps me focus my learning, basically. So I like to look at test-driven development, patterns and principles, like the solid principles and all these things, and then clean code as defined by code that is self-documenting. You read it, it reads like English, it's really easy to reason about. So for TDD, we're going to touch on that at the end of the presentation. We're going to kind of build up toward that. For clean code, that could be a talk all of its own, but instead I'm going to refer you to Robert Martin's book. You've probably already seen it. And now let's look at patterns, right? So that's why I didn't get to dig into yesterday. But so if you look at most programming languages that we work with, they support more than just one paradigm. You got object-oriented programming. You've got imperative programming where your system can have some state. You can start persisting state in variables. Procedural as a subset of imperative, where you can kind of delegate functionality to procedures. And then you got functional programming, right? And these days, if you look at kind of the way most complex software is being built. There's a lot of excitement around functional, and there's a lot of excitement around OOP. So I always want to be inclusive of all paradigms. I think the key thing, whatever paradigm that you work with, whatever language that you work with, you should try to understand which paradigms it supports, how well it supports those paradigms, and then try to find best practices and patterns that play to the strengths of those paradigms. And because in the end, the whole purpose of patterns is to simplify the complexity of a system, right? It's, I'll see people diss on OOP, but they're not really truly adopting OOP practices, right? They, violate the law of Demeter. They do, they leak too much information from objects. They don't do the tell, don't ask kind of policy. So if you work in functional, try to find functional patterns, right? So here, I'm going to give you a link to to these slides, but I have a link to functional programming patterns. It is a talk by Scott Lashin, who runs the website F# for Fun and Profit. I highly recommend it. He's got a lot of really interesting patterns on functional programming. He's applying them to F#, but they're applicable to functional programming in general. And as far as OOP goes, for some time we've had the solid principles, the Gang of Four design patterns, the Martin Fowler's enterprise application patterns. So these are more biased toward object-oriented programming and usually with a type system. And it works really well with PHP, right? And with PHP, we can apply all of these patterns. So I have some links here. I don't know if you've ever seen Design Patterns PHP.readthedocs.io. Great resource. It has all of the Gang of Four design patterns explained with concrete examples in PHP. So it's a great reference. I look at it, all the time. Whenever I'm trying to solve a problem, I'm like, yeah, I'm pretty sure there's probably a pattern for that, so I'll kind of go back to it. And if you're interested in functional programming, like I said, Scott Lashin's talk here, that's a link to it. If you've ever worked with Java, when they implemented streams, it made things very interesting, so I have a link to that. I have another link to use cases for functional programming by Robert Martin. And I have another link to Anjana Vakil's talk on Intro to Functional Programming, which is also very excellent. So to get back to object-oriented programming, with my team, I looked at kind of what patterns we use, ranked from most often to kind of least often. So P0, we use it all the time, right? P4, we every once in a while. So, dependency injection, all of these, we tend to use them pretty often. And so I'd be interested, to hear from you guys what kind of patterns you guys come across in your applications. I think it's always interesting to see how people solve problems. So this was patterns. They matter. So we just looked at enablers for better code, test-driven development, which we're going to get back to, the clean code, the book, and then we just kind of looked at references to kind of learn more about patterns and how to apply them. But I want to drill down a little bit more with object-oriented programming. Because there's this thing that I feel that we do very often, which is kind of flaccid OOP. We'll create classes, we'll instantiate classes almost anywhere in our system, and then we kind of end up with something like this, where we have a lot of components that live in different classes, and you got more components, and they all call one another, and then we end up with like a lot of tight couplings. It makes things very difficult to test, but also, what often happens is if we change one thing, because of all of these tight couplings and those dependencies, we'll tend to break a lot of things if we change anything in the system, right? That's not what we want. Obviously we want to achieve a simple, maintainable system. And to do that, we want to have loosely coupled components so we can also show a consistent dependency graph. And a way to achieve all this, that's what design patterns are for, right? So now if you get back to that large system and you have all these components working together, now they're all nicely isolated, right? They're not kind of intertwined together. So now it's a lot easier to change something without breaking everything, right? So at a high level, I just kind of want you guys to kind of keep this mental picture. All right, so that was for OOP. So then let's get into web application architectures. Because this concept of decoupling things is going to be relevant in the architectures that we operate in. So everybody is very familiar with MVC, right? That's anytime we build a web something, we tend to use some kind of MVC framework and kind of operate within this paradigm. And it's, in my experience, I've found it useful as long as there's a very close correlation of every URI with whatever database table that you're trying to modify, right? So if you're trying to edit a user, okay, that's fine. If you're doing one CRUD operation per given URI, then things work pretty well with MVC. But in my experience, it tends to not be the reality of most applications that I build. They tend to have a lot more complex business logic. And that's the thing, in many times, applications may start out just as being simple CRUD to the database, create, read, update, delete, CRUD. And they start very simple, but then they get more complex. They get a lot more business logic. And that's the thing is you want to have a layer for the business logic. You don't want to put all your business logic in the controllers because the controller is very much tied to the URL, to HTTP. It just doesn't quite fit well in the controller. So then people are like, okay, well, let's put it all in the models. But okay, your models are also responsible for getting data in and out of your data store. Do you also want to overload them with business logic in there? And so in the end, we don't have to confine ourselves to those three layers, M, V, and C. We can create classes as many as we want. But so we're going to come back to that. Now let's look at framework coupling. Because what often happens when we work in Laravel or Symfony or, help me, Cake 2.5, we tend to write our code in a way that's pretty tightly coupled to the framework, to the framework's middleware upstream, the controllers. And then downstream to the framework's data persistence layer, right? We tend to have everything just kind of very intertwined together. And it makes things definitely harder to test because everything is coupled to the framework. Now, in an ideal world, and actually in practice, it is perfectly possible to leverage everything that your framework has to offer without coupling your business logic to it completely, right? You should be able to always have a clean isolation layer between your business logic and your framework. It's just that when you look at a Symfony tutorial or a Laravel tutorial, they're going to show you, extend our base controller and then create your method and then put all your business logic there and then you're done, right? That's kind of what they show you, but we're also our own free-thinking people, right? We can make our own decisions, so and we should. So to address these challenges, we've arrived at this architecture which really are just a collection of patterns taken from Fowler's enterprise patterns, really. I mean, it's pretty simple. I'm sure you've all worked in something similar or seen something similar. But the goal here is to keep the views and the controllers You know, the views and the controllers are very much going to be coupled to your framework. And we're going to keep them at arm's length. So then in this green box, we're going to have commands, services, repositories, you know, entities, maybe data transfer objects. And if you look at everything in this green zone, that's basically your business, right? And everything in this business layer is pretty much framework agnostic, right? You could take all this code that may be in Laravel today and then just put it in Symfony, and it shouldn't take you too much time to do that. So the goal is to keep the controllers really, really thin. A controller should do very little more than just extract some data from the HTTP request, from the session, and hand that over to either a command or a service. But the key here is anything that's in the green zone does not care about the transport layer, right? You should not be invoking any kind of HTTP construct inside of the green zone. You should be passing primitives into it or objects into it. So your services, you could think of your services as the high-level capabilities of your business. It could be the closest thing to your API that you could think of, right? In my experience, the command layer, I don't always put it in there, right? Command classes are very small classes that interact with one or more services, and the name of a command class reads almost like the use case. Add feedback to user. Add comment to the feedback to the user, right? They're very specific class names. So in a project, you may have dozens of services. If you have dozens of services, you may end up with 40, 50, 60 command classes, for example, right? And those command classes capture all the use cases of your system. The repositories, or what we do in there is just, it's basically work with the data layer. So in my experience, what we're doing is we've been using Doctrine ORM. We will inject Doctrine ORM as a dependency to the repository. We also put clean interfaces between our architectural layer. Right, you'll see an interface between the command and the services, and you'll see an interface between the service and the repositories, right? So if I want to fake out, if I want to put a test double between architectural layers and my test layer, it's not a big deal, it's very easy to do, right? So, but the nice thing about the repository pattern is that if you wanted to, you could implement polyglot persistence. You know, right now you hear a lot of debate about SQL versus NoSQL, document stores versus relational databases. You know, in the end, there are very valid use cases for both. I don't subscribe to the idea of we should be using NoSQL for everything. At the same time, I do see some really good uses for it. In the end, the right architecture should allow you to be flexible enough to change your mind about what your persistence layer should be, and even have multiple types of persistence layers in your application, right? And the repository pattern kind of makes that easy. You could have some repositories into which you inject an object relational mapper, like the entity manager from Doctrine, and some other repositories where you inject a object document mapper. So Doctrine also has an ODM, right? So this architecture has worked really well for us, and it's made test-driven development a lot easier because we can very easily test drive our repositories, very easily test drive our services and the commands as well. I have a clean separation between the layers. I have nice interfaces between them, so it makes everything a lot simpler. So here I have a link to polyglot persistence. So I'll show you how to get the slides on the joined in. You'll be able to download the slides. So these slides just kind of go over what I just talked about. If you're interested in learning more about clean architectures, I have a link to an article and a link to a video, both by Robert Martin on the subject. All right, so we just looked at application architectures. So now that we've got a slight kind of better understanding of architectures that promote decoupling, and we understand with OOP kind of how to work decoupling and the way we think about OOP, it's going to help us with test-driven development. And here I'm saying better fuels faster. What I'm trying to dispel is this thinking that doing test-driven development automatically makes you slower. I'd like to show that it can actually help you ship things faster because you're doing a lot less clicking around, and we're going to look at some of that overhead. So yesterday I had a whole talk on why do TDD, but to kind of sum up that that talk, I'm going to touch on speed. But the key point of my talk yesterday was about being able to embrace change, whether it's new requirements, new features, but to also be able to constantly improve our code, right? Because that's the need that we feel, but we're always scared of improving our code because we're always scared of breaking things. But if we're doing test-driven development, that fear tends to go away. So one of the things I called out yesterday was that the nice thing about TDD is you may not start out your system with the optimal patterns, with the cleanest of code. You may kind of compromise on these fronts. But with TDD, you can incrementally improve things without fear. So now I want to separate two things. There's unit tests, and then there's test-driven development. A lot of what's being done today is a lot of code gets written, and a lot of code gets manually tested, and then we think, okay, well, we need to have a regression suite, so we'll go and write some unit tests after the fact, right? It's not dramatic. It's just not. It's a bit redundant, right? It's like you've already written a bunch of code, you've already tested it manually, and now you're replicating the manual testing that you've been doing with unit tests after the fact, right? Test-driven development is different because you first have to write a failing test before even writing some code, right? So you already have that. Anytime you're going to write code, you're going to have a mental picture of what your code should do. All TDD asks you to do is to write down what that mental picture you have, what that is, what the expected behavior. Just kind of write it down. It takes 30 seconds. It's really fast. And then you just write code to make those assertions pass. So the thing is, there are a lot of TDD tutorials out there on the web, and they're very useful. I encourage you guys to look at them. But they're always for pretty simple algorithmic problems, right? It's rarely, show you how to build a web application from scratch or like a web service from scratch. And that's kind of what I'm trying to solve with this talk and some of my tutorials as well. So, because web applications have several architectural layers. They have a lot of classes, right, that kind of depend on one another. And they're also heavily data-driven, right? Anytime you build a web app, you're going to be handling a lot of data. So what are some goals? I want to be able to get the satisfaction of building business functionality within the comfort of my test harness. All right? I want to be able to solve all the business problems inside of my test harness without kind of having to worry about the UI or a lot of things that don't materially impact what my business logic is. So that's something I'd be interested in. So to show you how to get that done, first I want to paint a picture on where we waste time. So anytime, if you're not doing test-driven development, anytime you build something, one of the first things we'll do is set up a local database, right? And probably add some database tables. We might use a tool to scaffold a basic user interface so that we can have something to start with. Then finally we get to write some business logic, right? That's the thing we actually care about. But then, we're going to use a manual debugger to step through code because things don't always work the way we want. And if we're not using a debugger, we might add a bunch of print-R statements or use a logging tool to log a lot of intermediate behavior through our code. And yeah, we're going to break things as we build new things. Yeah, that's kind of, we do that, right? So we waste time today while building things. Now, once we've built things, now we're going to test things. So everything that's in red, in my opinion, is bad. What's in green, that's what we came here to do, kind of write that business logic. So when we test things, we wrote all of this code, and now we ask ourselves, does that code work? Okay, well, how are we going to do that? We're going to probably click on the UI, or we're going to whip up Postman to hit our API endpoint. Or we might also visually inspect the database records, right? So if you wrote some business logic, chances are it did something to your data. So we're going to look, we're going to go in SQL Pro and kind of inspect database records to see that things are what we expect. Or sometimes we want to shortcut all the UI steps that we have to click, so we'll modify some database records to kind of jump the application in the state we want, right? I mean, some of these things may sound familiar, right? Sorry, went back in time. Yeah, so the point I was making is across those two slides, all activities that I marked in red, if you think about it, they're kind of throwaway activities, right? They're only relevant once when you do it, and you have to do it repeatedly. If you think about it, think about how much time we're wasting today doing all of these things. Wouldn't it be nice if we could always be coding? There you go. Testing is for closers, I guess. We could say that. So if I'm working in a TDD workflow, all I'm ever doing is coding against assertions. So the first thing I'm going to do is write a failing test, right? So I've already jotted down what I expect my code to do. Then I'm just going to write I'm going to write just enough code to make that test pass, and then maybe I might refactor some code, right? And that's your TDD workflow. Now, notice how all those red things that I had pictured on the previous slides, how they're not here, right? In a TDD workflow, you can operate in that. And now, if you think about it, you can start moving really, really fast. You can start solving business problems really fast. And that's the thing. These activities in green, they're foundational activities. They're always relevant because every time you build something new, you've got a test written out for it, and it's got your back. It's that test always answers that question for you of, does my code work? So, this is where things get interesting. We want to introduce meaningful data into our tests, right? Because that's another thing I mentioned about the challenges of web applications development is we deal a lot with data. How do we make that happen? Was anybody at David Letterman's talk earlier this morning when he did coupling your tests to your production code? Okay, yeah, that was a great talk. It kind of touches on very similar topics. So here's what we did to make it work. So picture an X-unit test harness, so PHP unit, right? An ORM that lives inside of PHP unit, and an in-memory database. So now imagine your ORM inside of your test harness backed by an in-memory database. And David, in his talk, he touched a little bit on that earlier, right? So then we start writing every unit test on top of this. And the way we achieved this was by using PHP unit, using the Doctrine ORM backed by SQLite. Does anybody here use Symfony? All right, cool. Yeah, Symfony, it's very trivial, right? In the config file, you can, in the test config file, you can tell it use PDO SQLite. And there you go. So before we dig into the workflow, I kind of want to clarify a few things. Some things that we want to avoid when we work with test-driven development. We want to avoid less than 100% coverage. Sure, there may be exceptions, and that's fine. I'm saying we want to avoid it. In my experience, we've been able to do it on a code base where we have almost 3,000 tests, and they 100% cover our source directory. So it's doable, right? But your priorities may differ. But typically, if you go below 100% code coverage, it means that somebody wrote some code that was not there to satisfy a test, which means somebody isn't technically doing test-driven development. It's not the end of the world. Sometimes we catch ourselves and we fix it. It's not that big of a deal, but it's an interesting signal. Now, the other thing about code coverage is it's not a silver bullet, okay? Because it is absolutely possible to have 100% code coverage and actually test nothing, because you can call your code, but you could have no meaningful assertion against it, right? Just say assert true equals true, and okay, you just call your code and you're not checking for any behavior, right? So, take code coverage with a grain of salt. And this is why code reviews are very important. So sure, we're going to use tooling to measure the code coverage, that's fine, but what really matters are peer code reviews. One of the most effective things that a code reviewer can do is to look at the tests and ensure that they can understand the tests and verify that the tests actually are relevant to the business requirements that we're trying to implement, to whichever user story we're trying to implement, right? That's the most impactful thing that a code reviewer can do. Okay, so with these things in mind, now let's look a little bit at a TDD workflow. So we looked at this architecture. I've seen TDD being done in all kinds of different ways. What I care about really is this purple box, the business logic, right? And if you think about it, upstream of the business logic, you have your controller, you get your routes, you've got your UI, and then below that, you've got your migrations, you've got your database schema, and that's it, yeah. So now you have all those intertwined concerns, and it is possible to do test-driven development more in an acceptance way where you're kind of doing it full stack. I don't like doing that because it just takes way too much time, right? Where you do TDD all the way from the UI, all the way to the database, right? I like to keep things more at the unit level, but some people do that, and in my experience, it makes for a lot less productive TDD. So what I like to do is kind of separate things out, right? Put my business logic in its own little box up there, and then I do not worry about migrations. I do not worry about the UI, my routes, and my controller, right? I solve all of my business problems on its own by TDDing my entities, my repositories, my services in rapid iterations, right? I'm just kind of working with within these architectural layers more at the unit level. Cool? So once I have solved a number of business problems, at some point I do want to test things full stack, right? I don't want to just, ship and pray that it works, right? I actually want to test everything. So I'm going to lean on my ORM, in our case, Doctrine, to automatically generate migrations from my entity graph. And that's kind of the beautiful thing about Doctrine is you can have all of your entities already coded out with all of your annotations. And when you run Doctrine diff, it'll look at your MySQL connection and look at your differences and automatically generate the necessary migrations to bring your database in sync with what your entity graph is. So once I've done that, then I can start hooking my controllers and my routes and my UI to it, and then I can do some manual testing, right? But the key here is I'm not worrying about these things at the bottom of the screen constantly, right? I'm not constantly doing these things at the bottom of the screen. I just kind of do it once in a while, once I've already solved a bunch of problems. So the workflow now looks like this. I might first TDD my repository, TDD my service that uses a repository, kind of repeat. Meanwhile, I could have somebody else on the team build a UI concurrently. They don't have to worry about my business logic just yet. And then I TDD more services. And then finally, I'll map the URI, create the migrations, run them, and then test the application through the application through the UI. But what matters here is that think of it as zone 1 and zone 2, and they are decoupled. So there you go. So I have an example of a ride-hailing application. So this is a kata that I've done. Okay. This is a kata that I've done, and I have videos on my YouTube channel. I'll have links to that. And the goal was to have a repeatable exercise that is of something not trivial. So I did that. So this is my app test case class. All of my unit tests extend from that class. And the first thing I do is I get the ORM. At the top line, I get the ORM. And so then I can pass it to my repositories. And then at the bottom, the setup entity manager. This is what kills the schema and rebuilds it for every single test. The nice thing now is that in my repositories, when I I can actually test drive my repositories with, let's say, DQL strings to retrieve data. And I'm actually testing this functionality for real in memory. So it makes things a lot faster. So this is the first test. The first thing I want to do at the top left, you can see test, create, and save user. Once I can create a user, then I'm going to assign the driver role to the user. I'm going to write another test to assign a driver role. Then I do another test to assign passenger role. And as I go, I'm refactoring my tests to reuse things that I've done in my previous tests. All right, here I make sure that a user can have both roles. I also have a test to make sure that if you're trying to assign the same role to the same user, it will throw an exception. So that was for the repositories. Now I have the services that use the repositories. So you'll be able to see all this code online. I'm not going to bore you too much with it. So the finished service test is on the left, and the service class is on the right. And here's the finished repository. So this one is a bit longer, so that's just the repository. And then here's my user entity. So here you can see all of my ORM mappings. And again, they work. I'm able to verify that those mappings work inside of my test harness, inside of PHP unit, by using Doctrine with SQLite inside of the test harness. So that's the role entity. Here you go. So next step, create the migration files, create your routes, deploy the code, win. So yeah, if you want to see it in action, TDD vids on Bitly. I have like 7 hours of videos, me kind of building this thing out. So, and all of my code is on GitHub, so you can look at the master branch and kind of have fun with it. So, boom. Okay, all right. I got some more reading also on those slides, some more articles by Uncle Bob. xunitpatterns.com by Jar Mazaros, which also, there's a book that was written that kind of has the same content as the site. I like the site because it's hyperlinked, so it's really easy to reference things. If you're interested in working with legacy code and kind of how to wedge unit tests in your legacy code, Martin Fowler has a great book about it, but I prefer Michael Feather's book about it. But they're both really good resources. So, boom. All right, so yeah, some benefits. You know, you can keep things decoupled. You don't have to worry about your UI when you work on your business, or vice versa. You can get in the zone, stay in it. It's a lot easier to stay in the zone when you do test-driven development. And if your boss distracts you, it's a lot easier to get back to it because you can look at your last test. So. And yeah, you don't need to worry about optimal design right away. That's the nice thing about TDD. Everything can be very incremental, right? You just implement first, optimize later. You're not afraid to do it later on because you got your tests. And you get all these things. All right, so that was TDD. The case I try to make here is that TDD helps fuel faster development by doing a lot less redundant things. So it's really, I'm trying to show that, we shouldn't try to pit better against faster. It is possible to have better fuel faster development and become more agile in the process and have a lot more fun. So we can do a lot less of crawling through a river of crap. Sorry, I kind of reused my meme from yesterday, but there's that. And do a lot more of better software by applying all these 3 things. And have better software at the center of your Agile stack. That was kind of a topic I covered yesterday. So you can have constantly increasing business value because you can constantly release new features kind of at a sustained pace. And again, sorry, I reused that meme from yesterday as well. So that's it. I'm not going to hold you back for questions. I'll be here. You can always come to me with questions. I want to let everybody go to lunch. Oh yeah, message announcement from Puss in Boots. If you guys could be kind enough to give me some feedback here, that'll be the most effective way for me to improve this for future generations. So thank you all for your time. Appreciate it.